Hello everyone, we are Team Linear Depression and our problem statement is agri-tech to AI-based water irrigation system with dynamic water optimization. So the problem right now that farmers face is that there is a lot of manual effort and the irrigation system is based on fixed schedules and not based on what are the crop requirements. So this problem will be solved by our solution which comprises of hardware system and AI system. So what will happen here? Our AI system will be comprising of some sensors and some controllers. Some sensors will be spread on the agricultural field that will take some parameters like temperature, humidity, moisture, etc. and feed it to our AI system. Our AI system will predict depending on the crop that how much water will be needed for that specific crop, and then that data will be supplied to the irrigation pipeline, and then the water will be supplied accordingly. So overall, this is an oversimplified explanation of our solution.
So we are using AI for our irrigation based system, and since AI needs real time data, hardware provides that real time data. So let's look at our hardware. Here we have used an ESP8266 which acts as a brain of our field. This will be planted in each zone along with some sensors, and here we have used DHT sensor which senses the temperature and humidity, but later in our hackathon part we will also use soil moisture sensor, pH sensor and turbidity sensors. And here as we can see, the temperature and humidity is being constantly updated to the backend, and after 3 seconds this backend is then updating the front end part. And this dashboard is not actually our part of prototype. During our final prototype we will make the dashboard.
We saw how we use electronics and sensor data. Now I will tell about how our AI system works. Now farmer doesn't keep their motor on 24/7. They start their motor in some time intervals to keep their equipment safe. Now we need to replicate that. For that, I need to predict or I need to make sure that the moisture remains intact until the next time I start the motor again. Now this depends on many parameters and variables, and for that we can't use classical programming. So we use artificial neural networks. Now our one problem is solved. But if the water supply is limited and we need to prioritize some crops over others, for that we used AI optimization techniques. Now all of these AI algorithms and artificial neural networks and sometimes external APIs make a single AI system.